So the big picture for this lesson is using a calculator to do statistical modeling of data. And we're going to look at two different types of data, one variable data and two variable data. Let's look at the one variable data first. So what that means is you just have a single column of data. And there's some data in the lesson, quiz scores, so I'm going to enter that in the calculator. Stat, and then 1 for edit. Well, looks like there's some old data in here, so I'm going to get rid of that first. If I go up to the list name and then press clear and then enter, it will delete all the data. So now I'm going to enter the data. Okay, now I'm going to quit, so second quit. And you want to be following along with your own calculator or with Desmos or some other statistics calculator. Actually, I'm not sure if Desmos does this one variable statistics. It might, but you need to find some type of a calculator that does one variable statistics. And you can just Google one variable statistics calculator, and I'm sure you can find something. Okay, so here's how you find the one variable statistics. Go to Stat, and then over to Calc. And then option 1 is one variable statistics. So pretty straightforward. I'll just put enter, enter, and then enter for calculate. And here's what it tells me. It tells me the x bar, which is the mean of the data. And the sum of x is the sum of the data. Sum of the x squareds is the sum of the squares of the data. And some of these we aren't going to be using. Sx is the sample standard deviation, which is part of the data. Sigma x is a population standard deviator. That is one we're going to be using. And that sigma is a lowercase sigma. So it looks kind of funky. That's the 15.417, so on and so forth. And the n is the number of data points. That's 8. And then I'm going to press the down arrow to get to the rest of this. And it'll tell you, this is the quartile data. In case you were making a box and whisker, it tells you the min, the max, the median, and the quartiles. So for our purposes, we're going to be dealing with standard deviation. And basically, the bigger that number is, the more spread out the data is, and the smaller means it's closer together. And also there's some conversation about outliers. Outliers are numbers that are far away from the data points. And so you may be asked to determine what outliers are and then redo calculations by removing the outliers to see what the results are. And now we're going to take a look at bivariate data, which means there are two variables involved, or two columns of data. And you can use a graphing calculator like this, or you can use Desmos, some type of online calculator. There are links in the course resources page, whatever works for you. So what we're going to do is we're going to use technology to model data. And I'm just using the data that is included in the lesson. In fact, for whatever calculator you're using, you should just go through the steps that are in the lesson. I'm going to run through them here as well, but you want to do these yourself so you can learn the entire process, and that way you'll be much more successful. So the first thing I did is I entered the data. I went to Stat and then Edit, which is option 1, and I entered in the data here. That's from slide number 4 from the lesson. So all that data is in there, L1 and L2, list 1, list 2. Okay, and I'm just going to quit now that that data is entered. Now if you want to view the data on the graph, what you need to do is you need to turn on the stat plot. And if you look, there's a stat plot button right here, so I can go second and then y equals. And then I want to turn plot 1 on. So I'm going to enter on the on. And you can choose the type. We're just doing a scatter plot, so what's there is fine. Notice that there's also bar graph, box and whisker, but we're just using the first one. So I'm going to quit out of there. Let's go to graph and see what we see. Oh, there's a function in there from before, so I need to go to y equals, clear that out. And notice up here, plot 1 is dark. That means it's on. You can also turn on or off the stat plots here by going up there and hitting enter. Now looking at the graph, I don't see any data points. That means the window needs to be adjusted. So I'm going to go to Window, and then adjust the scale on the x and the y. So the x max, well, let's see, what was the x max? I think it was 100. And then the y max, I think was, I don't know, what was it? The y max was, I'm just going to say, I'll put 20. So graph that and we'll see what happens. Okay, now you can see all these data points out here. So what we're going to try to do is find the line that best fits this data. So I'm going to quit out of here, and I'm going to do a linear regression. So stat, and then calc, and I'm going to do linear regression, which is option 4, and then just use the default values. Enter, 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 enter. Okay, so it's y equals ax plus b, just like y equals mx plus b, where a is the slope. So the slope is about 0.21, and the y-intercept is about negative 7.31. There are these numbers, r squared and r. Now, r is the correlation coefficient. This tells you how accurate your model is. So the closer to 1, the better your model is. Closer to 0, the further off it is. If you don't see this, you can turn it on by going to Second and then Catalog, and then you have to scroll down to Diagnostics on and then enable that. Again, all this is shown in the lesson. Okay, so now, what if I want to view the line on the graph with the data points? So what I'm going to do is I'm first going to go to y equals, and then I'm going to go to Variables, vars, and then I want to choose option 5, statistics. Then I want to choose the equation. And then the regression equation is option 1. See how it puts the regression equation right there for y1, enter, and then graph. So there you can see that regression equation. And it fits the data pretty well. Okay, now this is the steps for the TI-84 and similar calculators. If you're using Desmos, you'll need to do a Google search for the Desmos directions, but they're actually pretty straightforward once you find them. So you're going to be doing linear models and correlation coefficients, and that's the big picture for this lesson.